Hello, this video is for IXL, activity 6.I.8. It is titled Convert Between Improper Fractions and Mixed Numbers. The 3-character code for this activity is Papa Niner Alpha. So, an improper fraction. What is an improper fraction? And what is a mixed number? So, improper fractions are fractions in which the numerator has a greater value than the denominator, such as say 79 over 16, right? 79 has a greater value than 16, so this is an improper fraction. A memory device that I've taught for several years, or used for several years to remember what an improper fraction is I ask the question, which is greater, or which is bigger, the horse or a man? And of course, unless you're talking about a very small Shetland pony, the correct answer is a horse. The horse is bigger than the man. So it would be proper for the man, who's smaller than the horse, to ride on the horse than it would be for the horse to ride on the man. So the horse riding on the man would be improper, whereas the proper thing to do would be for the man to ride on the horse, because the man's smaller than the horse. So the horse is big enough to carry the smaller man. That would be the proper way to do it. It'd be kind of silly to see some small man trying to carry around this large horse on their back. So improper fraction, numerator's greater than the denominator. So let's go ahead and talk about how we convert that to a mixed number. And you might be saying, well, what's a mixed number? Well, think of it this way. You could have a jar of peanuts, or you could have a jar of cashews, cashews being a form of nut also. But if you put them together, you would have mixed nuts. Well, likewise, you have mixed types of numbers put together to create a mixed number. Here in 7 and 9/10, 7 is an integer and 9/10 is a fraction, right? Kind of like a rational number. So if you put them together, if you consider 7 just by itself, you're like, okay, that's an integer. And if you consider 9/10 by itself, well, that's a fraction. But if we put them together, then we kind of got a mixed concept there, and that would be a mixed number. So a fraction with a number in front of it, or a value out here in front of it, that's known as a mixed number. Now, how to convert from one to the other and have it to where they are equal values still is what we're going to talk about in this particular video. So the conversion of a mixed number, you can see here the A is representing our integer out in front of the fraction. The B is the value of the numerator, and C is the value of the denominator. Well, what you do is you multiply A, or C, the denominator, times A, the number out here in front of the fraction, and then you add to that the value of the numerator, B. So here you see A times C plus the value of B, and also note that the denominator remains the same. So if whatever the value is over here, whatever C is, it's going to remain the same over here. So let's go ahead and take this whole algebra representation of it, where we're just using letters, and actually put that to work with the concept here of 7 and 9/10. So in this case, let's rewrite our problem, 7 and 9/10. And my numbers aren't going very well today. There we go. And we know that this is equal to 10 times 7. So we're going to take 10, multiply it times 7. And then we're going to add to it the value of the numerator, which is 9, and the denominator is going to stay the same. It's 10. So 10 times 7 is 70, plus 9 is 79, and the denominator stays as 10. So we see that 7 and 9/10 is equal to 79 over 10. Now let's go ahead and talk about how do you convert a mixed number to an improper fraction to a mixed number, going back the other way. And one thing to note is that all fractions are division problems. It's just another way to write a division problem. So 25 over 7 is the same as 25 divided by 7. So we could set this up as a division problem. 7 goes into 25 3 times. 3 times 7 is 21. We do our subtraction. 5 minus 1 is 4. So 4 is our remainder. Now you might have remember from grade school where they would have you do something like this. If it's, say, 25 divided by 7, 7 goes in 3 times. 3 times 7 is 21. 5 minus 1 is 4, and your teacher would say, and then take the remainder here, and you write a little r and go remainder of 4. Well, how it works out is that the number here, your quotient, I believe, you got a quotient, a divisor, and a dividend. I believe this is the quotient here, 3. That becomes your whole number out in front, or your integer out in front. It could be negative, I suppose. And your remainder becomes the numerator up here at the top, and your denominator still stays the same. So 7 went into 25 3 times. 3 is the number out here. And the remainder is 4. That's your numerator. And 7 was the denominator, so it remains the denominator. Keep the same denominator. So let's give that a try with this one here. We're going to go ahead and take 65 over 6, and we realize that is the same as 65 divided by 6. And 6 goes into 65, well, 6 goes into 6 once, right? And then we're going to subtract, get 0, bring down the 5. 6 does not go into 5 at all, so the remainder is going to be 5. So we'd have remainder 5. So we can then take this and say 10. Sorry. 10 up here is our integer out front. Then we have the fraction bar. 5, our remainder, is the numerator. And the denominator of 6 remains the same. So 10 and 5, 6. So we'll go ahead and do some conversion of improper fractions to mixed numbers and mixed numbers to improper fractions. So we're going to go ahead and rewrite our problem. 3 3/4. This is equal to, we're going to take the 4 from the denominator, multiply that times the integer out front, 3, and then add the value of the numerator, which is also 3. And all that's still over 4. 4 times 3 is 12. 12 plus 3 is 15. And we're going to keep the 4 there. So 15 over 4 would be our answer. On this one here, 9 7/9. What is this equal to? So I'm thinking, okay, do I want to keep doing it this way? Or actually, let's do it this way. 9 times 9 is 81. 81 plus 7 is going to be, what, 88? And we keep the denominator of 9. Right? So you don't have to write it all out this way. As a matter of fact, you'll probably get used to where you just kind of look at it and you'll be like, let me see, 9 times 9 is 81, plus 7 is 88. So it would be 88 over, and then the denominator is 9. Let's go ahead and change some improper fractions to mixed numbers. 14 over 3. This is equal to 14 divided by 3. And 3 goes into 14, 4 times? 4 times 3 is 12. Do our subtraction. 2 is our remainder, right? So remainder of 2. So in this case, 4 is going to be our integer out front. We have a fraction bar. The remainder of 2 is our numerator. And we started with a denominator of 3 right here. So 4 2/3. On the next one, we have 110 over 17. And you can ask yourself, okay, how many times does 17 go into 110? And what you can do with that is, and I think I'm going to, hold on, I'm going to pull my calculator up here and show you how to, All right, so I moved my problem over to the side and I got my calculator here. And I want to know how many times does 17 go into 110. So I'm going to do 110 and I'm going to divide that by 17. And I see that I get this 6 point, and I have this decimal number here with a 6 out in front here. So I know that 17 goes into 110 at least 6 times. So let's go ahead and put that on there. We know it goes in at least 6 times. So let's see, let's go ahead and write this out here. 110, and we're going to divide that by 17. And we know it goes in 6 times, so that's going to go over here. So I now need to know what is 6 times 17. So if I did 17 times 6, and that's going to be, what, 42, carry 4, 6, 10, that's going to be 102. And then I subtract, and I'm going to get, what, 8, right? And my remainder is going to be 8. So then I could go ahead and realize that 8 is my numerator, and 17 is my denominator. So the answer would be 6 8/17. On the next one here, we need to do 69 times 5, right? I guess, okay, Mr. T, be a good math teacher, rewrite the problem. All right, we'll go ahead and do that. So I need to do 69 times 5, and I'm going to go ahead and use my calculator here. 69 times 5 is going to give me 345. 345. Now I need to add 43 to that. That's going to give me my new numerator. So 345 plus 43 equals 388. And for the denominator is still going to be a value of 69. Here I have 10 and 4/17. 17 times 10, well, that's easy. That's 170, right? Just throw a 0 on the end. Now let's add the 4, and we're going to get 174. And our denominator stays at 17. Last two problems here. I have 121 over 37. So we realize that's a division problem, right? 121 over 37. And using my calculator, 121, going to divide that by 37, and it goes in 3 times. So I know my 3 is going to go there. Now I need to know 3 times 37. So 3 by 37 is going to give me 111. 111. So that's going to result in a difference of 10. So my remainder would be 10. So I know that my answer is going to be 3 from the up here, my quotient. The remainder is the numerator, and the denominator stays the same, and it's 37. 10, 3, and 10 37s. And finally, for the last one, I know I have 611 divided by 87. Remember, all fractions are a division problem. Just divide the top number, numerator, divided by the denominator. So 611, we're going to divide that by 87, and that gives us 7.0229 something. So it goes in 7 times, so I need to know 7 times 87, and that's going to be 609. And the difference is going to be 2, so my remainder is 2. That means that my number out front of the fraction here is a 7. My denominator is the remainder, which is 2, and my numerator, or my denominator, 87, stays the same. So those are all of my examples for IXL activity 6.I.8, convert between improper fractions and mixed numbers. Good luck with your activity.